Hello everyone, this is the Trimble Geospatial team here. Welcome to our first session of the new webinar series, Mobile Mapping Essentials. I'm joined by my colleague Peter Houghton, and today, we're talking about considerations when evaluating mobile mapping solutions. So the Mobile Mapping Essentials series is really, I think, a great starting point for everyone that's trying to find out whether mobile mapping is relevant for their organization. That's new to the technology, but we'll also be covering a range of topics for people that have already started working with mobile mapping. There will be more sessions coming up on this series, so please keep looking out for new sessions that are going to be announced on our webinar page on trimble.geospatial.com. Now I'm handing over to Peter.
Thank you, Sophie. Good afternoon, good morning, good evening, wherever you are in the world. I hope everybody's keeping well. So we're going to kick off the webinar talking about things to think about when considering a mobile mapping system. So I've tried to go beyond the kind of classic introduction to a product kind of idea and maybe highlight some of the things that should be thought about when evaluating a mobile mapping system. However, having said that, I will kind of use the Trimble MX9 as kind of the main example here, but I guess many of the points that I'm raising are valid for other systems too. So the Trimble mobile mapping portfolio, we have basically three products. The MX7, which is an imaging only system, the MX2, which is kind of an intermediate level laser-based system, and the MX9, which is a combination of imagery and laser data. Really, the MX9 is the only one that can be used, I would say, for survey kind of applications and deliverables, meaning if you wanted to reach engineering level accuracy, the MX9 is the product we have in that category. So again, here are our three products, and as mentioned, the focus of this webinar as an example will be the MX9 product. So a wide range of applications, but also suitable for collecting. Maybe this is the first key point, to be honest, is that allows you to collect large amounts of data. So maybe for somebody considering buying a mobile mapping system, would allow that person to, or that organization to consider much larger projects than perhaps they're used to. And then, of course, that in itself may have multiple implications for that organization. So the MX9 system itself consists of basically two laser scanners, a 360-degree camera, and then there's some ancillary equipment like the power unit, a control unit, and of course a roof rack. The system is controlled by a device such as a tablet, it could be a PC, could even be a mobile phone. You actually connect to it using Wi-Fi and operate the system using a web browser. The software is actually held on the MX9 unit itself. So let's have a look at the components. So firstly, we have a roof rack, which is supplied by Trimble and attaches to the roof of the vehicle. Then we have the MX9, what we sometimes refer to as the sensor head. So this is the cameras, lasers, GPS, IMU unit, and also significant amount of computing power. There is an optional secondary GNSS antenna that is normally mounted ahead of the main unit on the vehicle. We could also add what we call a DMI, or a distance measuring instrument, which is basically a wheel that attaches to the wheel of the vehicle and provides a further input for measuring distance in tricky GNSS environments. So how does it all look? Normally we would recommend installing a second battery in the vehicle, so a secondary regular vehicle battery. This is just to ensure that we don't drain too much power from the original car battery. Then that connects to our power unit that does some voltage stabilization, and then that connects to our control unit. The control unit has two removable SSDs for recording data. So the data is recorded to SSDs in that control unit, and these are removable and can be taken into the office from where the data can be transferred to a computer. Then there's a single cable connection from the control unit to the sensor head itself. So all these are single cable connections, so it's a fairly clean system and fairly simple to understand for somebody that's new to mobile mapping. And then we create a little Wi-Fi hotspot locally in the vehicle, and normally you would connect to that with something like a tablet, an iPad, or a Galaxy tablet, and then using a web browser, you would operate the system. You can also connect to the control unit with an Ethernet cable if that is desirable. So for example, if some people prefer to use a laptop PC, that can be used by connecting directly with an Ethernet cable. The software itself, I would say this is one of our Trimble advantages, is our simple to operate concept. So when we were designing the MX9 and its sister, the MX7, one of our goals was to simplify mobile mapping as much as possible and remove as much of the scariness as we could. The software that operates the system, we call it TMI. It's very, very simple. So basically, there's a settings screen. This is where you configure your vehicle, can change some laser settings, can take some measurements, but basically once it's set up for that particular vehicle, you just select that vehicle each time. There's not too many settings, to be honest. Then we have a very simple data collection screen, which I'll show a little bit later, that allows you to record data whilst you're in the field. And the goal here was to make it as simple as possible and to almost make it a one button click, stop, start kind of idea. And then there is a backup component to the software that allows you to manage your projects on the hard disk of the system and to transfer that data to an external hard disk or to a computer. So data recording, this is what the system looks like in the field. On the left-hand side is a kind of background map Actually, it's blank here. We don't have any background map in this particular occasion, but you could have a background map. On the left-hand side, on the right-hand side, you'll see some of the operations of the system. So you can see the current screen is showing laser profile as you go. There's a navigation screen, which is red if you don't have enough satellites or the IMU isn't initialized. It goes orange once you have enough position, and then it turns to green once the heading is within the specification and you're ready to record data. You can then hit the green button in the bottom right-hand corner, and this means start recording data. So data is recorded in what we refer to as runs, and a run is all the data that's recorded between a start and a stop. So once you have completed your data collection, you press the red button, it turns green again, and you've recorded a run. So what does the data look like? Typical data in kind of an urban area here. You'll see the detail of the buildings, and then of course we have many customers that are interested in the road surface itself. So just an example here of how manhole covers, for example, show up in the data. Another scene here showing some power lines and some buildings and the road itself. And then another one here, and you see things like the reflectivity of the road signs. You see how things like lamp columns show up very well, and even the barrier in the center of the road shows up pretty well. So a lot of detail from which we can extract data. Here's an example on a railway where you can clearly see the details of the rails. You can even use in, let's say, short tunnels. Longer tunnels where there's no GNSS, of course, become more of a challenge, and that's a different subject. But bridges, tunnels, etc., the inertial system keeps us going underneath those obstacles. So applications. The nature of a mobile mapping system means that it's very good for corridors, because generally we mount it on a moving platform, a vehicle, or on a railway, for example. Also, the data from an MX9 is good enough for engineering type surveys. So if you were interested in doing a topographic survey for design or redesign, this could be considered. Of course, as-built surveys following engineering works is also an application. The next two, utilities and asset management, we've seen a lot of use of mobile mapping for this kind of application, where the data is recorded along with plenty of metadata or attribute information, and the data generally ends up in a GIS system. An area where we've seen some significant movement is in the telecoms and fiber to home business, and some of the examples I'm going to show later on refer to this fiber to home business. This is where, you know, plenty of providers throughout the world are looking to extend broadband and internet coverage to people's homes, so fast fiber broadband, and there are some good applications relating to mobile mapping and that particular application. We've also seen users using mobile mapping for transportation clearances. So for example, if you have a very large or heavy load and you need to plan the route for that load to be transported, there's a lot of work goes into understanding the clearances, and obviously mobile mapping can provide some good input for that. And then also 3D modeling and creation of things like scan to BIM models is another area where mobile mapping can provide significant value. So some considerations. From a hardware point of view, relating to the MX9, we provide two IMUs. The IMU is the inertial unit that complements the GNSS receiver inside the mobile mapping system itself. And we offer two different IMUs. The most significant difference between the two is the price, which is why it's important to understand the differences for your application. The AP60 is the highest grade IMU, and this, I guess, will be the most ultimate reliable in demanding environments, has very stable heading, pitch, and general orientation parameters. The AP40 is slightly less, but not very much less. And for a user going for the AP40, we'd also recommend the second antenna so that we can calibrate the heading against the GNSS output. So AP60 versus AP40. Another thing to consider is whether to go for a single laser system or a dual laser system. The majority of time we've sold the dual laser system. However, for cost sensitive reasons, a single may be good enough. Of course, the main difference is that you only get half the LiDAR data in one pass. And for many applications, it will be enough. Quite frankly, the data is very dense, and you could argue that for some applications, two lasers is overkill. However, you do get this ability with two lasers to kind of look around corners and minimize the effect of shadowing in the data, because you've got two different angles that you can hit an object from. But of course, you can increase the density of a single laser system by driving the route twice, maybe in a different direction or from a different angle. So some things to consider there. Do I need a secondary antenna? We call it GAMS. The secondary antenna allows us to determine a very accurate heading from GNSS, and it's very useful for calibrating the IMU. So some effects it may have is it may give you a very good heading RMS very quickly. IMUs generally have this characteristic where they kind of need to warm up a bit, so it can speed up that process, but it can also be valuable when using a lower grade IMU. DMI is the wheel that fits on a vehicle. Do you need one? Things to consider there are, does it help? Yes, it helps in poor GNSS environments by basically providing a distance, an independent distance solution. So in GNSS challenged areas, it can help for sure, but if your project is in a wide open area, probably doesn't provide that much value. And also the tricky thing with the DMI is it's specific, fitting is specific to a particular vehicle. So if you want to swap between vehicles, that becomes more of a challenge. So in a typical 2 LiDAR system. This is the kind of pattern you would see in the data, so kind of a cross pattern with the 2 tilted scanners, in this case showing the pattern on the surface of the road. We call it a butterfly configuration. Some other considerations from a software and workflow point of view, things to think about when either deciding to buy a mobile mapping system or thinking about a particular project. So the application, and particularly what kind of deliverables are going to be required. So is your project or projects, is it about survey and engineering deliverables, or is it more about asset management and GIS deliverables? And that's important from the point of view of not only your field procedures, but also in terms of what workflow and which software products you're going to use to extract data. If you're mainly interested in asset management, you may use a different piece of software to survey and engineering kind of data. The next consideration is, do you want to extract data to simple files, simple flat files, so a file-based solution, or do you want to extract data with a database connection, perhaps to an existing database? So this can be typical for an asset management application where perhaps there is an existing database that is used for keeping inventories of asset information, or it could also be a GIS system, of course. So this is a second important thing to consider. Then the extraction environment itself, I would say there's 2 basic environments for extracting data from mobile mapping. One is more of a point cloud-based environment. So for those of you that are familiar with terrestrial laser scanning, I guess something more like, a Trimble RealWorks environment, which is essentially working on the raw point cloud itself to extract features. Or there's more, for mobile mapping, where there's more of an immersive imagery-based kind of technique where you're basically guiding your way through 360-degree images and using the images as the main interface between your eyes and the data itself. And the point cloud is kind of in the background in the image. This can be a very comfortable way to extract lots of data. Logistically, for an organization that is considering mobile mapping, they need to think about data extraction. Data extraction, depending on the products you want to deliver, could be enormous. So you need to think about, do I have an in-house team that can be trained to extract this data or is already familiar with it? Or do I want to consider outsourcing at least the extraction part of this process to a third-party company? And then finally, last consideration is data sharing. So when I've collected all this data and perhaps I've extracted some products from that data, do I want to share it? Is this data, for example, going to be used in a municipality where there is significant value in sharing the data across a large range of users and departments? Do I want to connect to a geodatabase, and do I want to use plugins? So, for example, if the data was on the internet, would I be interested in sharing that data and using plugins to to connect that data source to my GIS system, for example. Considerations from a software point of view. So TBC is great for survey and engineering deliverables, and then also, of course, for integration with other survey data from all my other survey sensors. So TBC is very good at that for producing survey and engineering type deliverables, you know, DTMs, profiles, cross sections, CAD line work and features, and then of course providing that data onwards in the engineering process for engineering design, potentially even taking something like the mobile mapping derived DTM into a machine control environment for building a road. An alternative consideration for software might be something like TMX, Trimble MX Software. This is very much more focused at asset management and GIS, and also for publishing and sharing the data. The extraction environment is very much kind of image based with a point cloud in the background, and because essentially TMX has a quite powerful GIS database underneath it, it's very good for managing GIS kind of data sets. And also another consideration could be whether to use a desktop version or whether to use client server kind of operation. So how to handle large data, things to think about, kind of a summary here: desktop versus client server, manual or automated or semi-automated extraction, file-based or database connection. Do you want data sharing and publishing, in-house versus outsourcing in terms of data extraction? And then finally, you know, whether you whichever of these a customer was to opt for, need to be aware that the data requires a significant amount of organization and management, perhaps the most challenging part of the whole mobile mapping process. So workflow inside Trimble, we start with our TMI software in the field, and then we process the trajectory through POSPAC. This gives us a clean post-process trajectory, and then there are a couple of ways we can then go in terms of data extraction, either in TBC for our CAD kind of engineering workflow, or in TMX for our mapping and GIS asset management workflow. So let's have a look at the workflow, kind of starting from left to right. So once you've come in from the field, the first thing to do is process the vehicle's trajectory to get an accurate centimeter level vehicle trajectory. So we have the raw GNSS and IMU data from the vehicle, and you need a base station to process that against. That base station, in most cases for mobile mapping, is a web-based, publicly available base station. So not many people actually use their own physical base stations, but use a publicly available base station. So the real-time trajectory is then processed through here, takes all the GNSS, IMU, DMI data, and gives us what is called a smoothed best estimate of trajectory, or an SBET. Then we would take that data, so our final trajectory, along with all our project data from the field, into Trimble Business Center. A point cloud is generated from that data, referenced to the trajectory, so it's now georeferenced in the right absolute position, and the images too are processed such that they now are coincident with the point cloud and are in the correct absolute geographic location. The next step in TBC could be, depending upon the application. So if it was a survey or an engineering application and you wanted to improve the accuracy of the survey even more, you may want to register that to control points. So this is showing an illustration of a survey of a road interchange or a road junction. We have several control points, as you will see on the right hand side, and we have two runs, basically one going from right to left and the other coming from left to right, and we would like to register both those runs to the control points and then also one run to another to get the best optimal resulting point cloud that we can. So those tools are available in TBC. The next job in TBC maybe, again, depends on the deliverable, but the next part could be to colorize the point cloud. So you would take your input point cloud along with the images and then use the images to colorize the point cloud in true color. From a computing point of view, this is quite an intensive process. It takes quite a lot of processing power and time, but in terms of operational complexity, it's very, very simple. The next process in TBC could be to classify the point cloud, and this is absolutely automatic. It will look at the point cloud and will try to classify automatically into 5 categories: buildings, ground, vegetation, posts and signs, and power lines. Even if you have no need to classify the point cloud itself, it can be very useful to aid operations for data extraction. So for example, let's say it puts all the ground points into a layer called ground. You can switch the other layers off and you just have the ground points. So you've got a very clean start, for example, to build a DTM. Similarly, if you wanted to extract posts and signs, you could switch off all the other layers, just look at the posts and signs, and gives you a quite clean environment to start extracting those features. So just this one just kind of summarizes a particular data set in Trimble Business Center. This data set is one I'm going to use in some of the examples I'm going to show you of data extraction. It's basically a housing area that needed to be surveyed because they were going to install fiber to home in this area. So it was driven with an MX9 and used to derive some of the parameters that are needed for fiber to home. Again, this just shows you it's quite a nice little video from TBC, where what I've done here is created a road center line and I'm able to drive through the point cloud in TBC. Okay, now a little bit about TMX software. It's kind of compare and contrast the tools available compared with TBC, for example. So Trimble MX software, it's quite easy to use, but there are a huge number of features in it. There are basically 4 main components to it. So Content Manager allows users that have huge amounts of data to manage that data in projects. As I mentioned earlier, managing large amounts of mobile data is not something that should be gone into without having your eyes wide open. It requires some tools and it requires some organization. So Content Manager is a product that can allow people to do that. Asset Modeler is the main environment, desktop environment that allows somebody to extract data using a desktop product. And Publisher is a way to publish the data over the internet, allowing that data to be shared across an organization to multiple departments. So Content Manager, Asset Modeler, and Publisher. I think I'll just move on as time's pressing on. So what data do we actually have to extract from? We have, we basically have panoramic photographs, panoramic images, sorry. We have a downward or backwards looking camera that's looking at the road surface. So this is useful for anybody that's interested in the road surface itself. And then we have some sideways cameras that are looking left and right as you move forwards. And then we have the point cloud itself. So if you like, the raw data resources we have to start extracting data. So I mentioned that a choice could be whether to use file-based operations or a database connection. So file-based obviously is simple, allows you to, copy and paste data using Windows Explorer in a very simple way. A database connection could be better for interoperability, and if you have multiple users wanting to extract data simultaneously to an existing database, and also allows connection to an existing database that is maybe something from before mobile mapping, if you like, so allows you to connect to an existing database for data integration. So TMX allows database connections. You need a driver to do this, and there are several what are called JDBC drivers or Java compatible drivers that allow you to connect to various SQL databases. So as you will see on the left-hand side there, several choices of several choices of database that can be connected to using this capability. So in TMX, the data comes in and it looks like this. So here's a map showing the vehicle trajectory and displaying the accuracy of the trajectory. So good QC tool. And then I'm going to show you an example of fiber to home where from a design point of view, they may want to plan the cable location and helps them plan if they need to dig a trench, what kind of material it's in, etc. They may want to measure offsets from the main cable route to every property. It's quite important in the fiber to home business because quite often the customer at that property will actually pay for this part of the operation. So the actual cable coming from the main route into their property. We also have some capabilities to query and filter the data in TMX. once we've collected lots of data, we can query it and filter it and export it. And then we might also want to, after this fiber to home process has been completed, maybe it's been done by a subcontractor, we might want to resurvey that and inspect that area to make sure from an as-built point of view that work has been undertaken correctly. So in this example, I'm just showing how we could plan the trench. So here we have a tool to extract basically a polyline. The rectangular, yellow rectangular symbol is showing that basically the system is snapping to the surface itself, horizontal surface in this case, which is the sidewalk there. And I'm extracting where I want my trench to go, and I'm giving it a surface type. I'm saying it's in asphalt, what kind of equipment is needed to dig the trench, and then automatically I've also stored some parameters like the length of the trench, etc. So that appears on the map, is in the database, and of course could be exported to a GIS system along with the attribute information that's been entered. Similarly, for curb line, so I'm just going to extract some data along the curb line here. So I'm adding data to the inventory. I choose which feature I want, curb line, and now I start extracting a polyline. So of course, this is a manual process. There are tools available for doing this also in a semi-automated way. So here we're just extracting the curb line. Of course, the point cloud is in the background here. So this is what I was mentioning earlier on about the environment you're using for extracting the data. The point cloud is in the background in those, although it appears to be just an image-based kind of idea. So attribute information also stored, the length of the curb, what kind of curb it is, and of course the information. The line work is stored in the database and can also be overlaid in the image. Here's an example of extracting a manhole. So in TMX, of course, you can extract points, lines, or polygons. In this case, I'm using a polygon feature. I'm extracting a feature called chamber or manhole. Fiber industry, they seem to call them chambers, or at least in the UK they do. So I'm extracting that as a polygon feature. It's automatically calculated the area because that's what I told it to do. And I'm just taking a few notes there in one of the other attribute fields. And you'll see that that data has been extracted with I've also asked it to display the area in the middle of the symbol. Similar idea now. I think the only difference here is another manhole. It's a circular manhole. So again, I'm using a feature called chamber, and I'm selecting, I think, 3 points on a circle. So again, the feature has responded. Manholes are quite important for the fiber to home business because they're interested in existing infrastructure and potentially whether that infrastructure could be used by them. So this particular customer was interested in collecting existing infrastructure. And then another item of interest was to measure the offsets from the main cable route to the property boundary. So as I mentioned, this is something that's of great interest because the customer or the owner of the property actually pays for this component of this operation. So obviously, basically that distance there is directly proportional to the bill that they're going to give the customer. So labeled 9.7 meters, etc. And then there are also, I think this is the final one, but just to give you a flavor for some of the more advanced tools. So again, I'm looking at the cable business here. Usually they, at least in the UK, they want to bury the cables as much as they can, but actually in many places, well, in most places, it's actually cheaper to suspend the cables from poles. So that is always an alternative as well, because it's very cost effective. So they may want to look at poles and see if there's room for them to install their existing infrastructure, install their new infrastructure on that pole. Here I'm actually just showing you some capability to measure catenary of suspended cables. So that's quite a nice feature there. Automatically populates 2 fields, span and clearance with the measurement. Also, once you extract any feature in TMX, it automatically creates a snapshot of that feature. So that's what that little thumbnail is there. Here's one showing some automated extraction. So this is extracting railway lines for a rail application. So there's a tool here. You basically click on one rail, show it the direction, show it the offset to the second rail, and it will automatically look for the high points on the rail and extract the rail as a feature. Similarly, again, this is a rail example, but it's using an edge detection. This could also be used for curb lines, but I'm using here edge detection to detect the edge along the railway platform. So you get a little edge detection kind of icon when you use this. You might see it more clearly here, where the icon changes to an edge when it detects the edge, and it automatically creates the platform edge. So data can, once data is extracted, can be exported to typical GIS formats or to CAD formats. And then I mentioned a couple of times, it's also possible to publish the data. So this is where you would have an in-house server with the TMX publisher platform installed, and it allows you to publish the data and allows people to access the data just using a web browser. So basically you can send them a link to somewhere in the data and they can click on the link and see the data. They can take basic measurements, they can do quite a lot of things in the data if they want to, but it's fairly let's say, basic and user intuitive that allows a non-expert to browse through the data. Once the data is published, there are also plugins for the data that allows you to use. So this one's showing ArcGIS plugin. So you can go into ArcGIS, you can install the TMX plugin, providing you have data that's published on the internet. You can then extract data using the tools available directly into ArcGIS. So there are similar plugins available for Autodesk, MicroStation, QGIS, I think, and some others. And there's also an SDK for other systems that may require a plugin. Finally, I just wanted to mention some things from to consider from a business point of view. So we understand the capital outlay for a high-end mobile mapping system is pretty high. So why would you want to do this? Well, mobile mapping, generally speaking, once you've bitten the bullet and bought a system, will provide a better, faster, and cheaper solution. So field to finish with high quality data could be 60% faster on a large project or even a small project. Fieldwork is likely to be 90% faster. So we're talking significant numbers here. Improved on-site safety, so no need for pedestrian access on busy roads, can all be done from the safety of a vehicle. No need for specific road or lane closures for undertaking survey operations. And for many companies, what we found is it expands their capability to take on much larger projects than they've historically been able to do. So something about productivity gains and something really to consider for an organization. These numbers don't hold me to these numbers, but they're just to explain the concept, if you like. If we said that conventional surveying, for every 3 people or 3 crews, you need 1 in the office to finalize, do all the CAD work, produce the deliverable from that field work. So it's a kind of a ratio of 3 to 1 field to office. What people need to be aware of with mobile mapping is it's much bigger in the other direction. The ratio is something like 1 in the field to 6 in the office. So obviously depends on the deliverables and the amount of data that needs to be extracted. But if there's a huge amount of extraction to do, if basically your customer wants everything extracted, then that kind of ratio is possible. So could have a big impact on an organization and the way that they need to think about mobile mapping. So something on return of investment. So as I said, relatively big capital outlay, but it will streamline operations. Individual project costs will be reduced. Also, things will be done quicker, allow people to accelerate schedules. improve quality and minimize risk and opportunity. I think once that capital outlay has been recovered, a real opportunity to increase profits. So large projects, the project's costs could be, I'm not including the capital outlay here, so large projects could be reduced by up to 50% their cost. So the trick here is to figure out how to address the capital cost issue. Basically, once the system has been paid for, you can consider mobile mapping to be a cash cow and something that can generate lots of revenue. That's it from me. I'd like to thank you for your attendance. I'd like to remind you that there's a follow-on from this presentation on Thursday, the 9th of April, which is going to focus on the workflows in TBC that follow data capture. So a kind of deep dive into TBC and mobile mapping data. I'd like to thank everybody for attending, and yeah, we will capture the questions as much as we can. Please feel free to email me if you want any further information, and I hope you enjoy the rest of your day. Thank you.